All right, let's take a look at some linear inequalities. These are things that look like 2x minus 5 less than 10, or maybe 2/3 x plus 2 less than negative 5, things like that. Okay, so we've got an x, and we've got some numbers, and they look like a linear equation, but it's an inequality. Okay, so let's look at some rules before we start. Okay, so rules for inequalities. Sorry, my pen's skipping a little bit. All right, so the first one is if we have a less than b, then that's the same as a plus c less than b plus c. Okay, so we can add or subtract a number as long as we do it to both sides. So this is the exact same as linear equations. We can add or subtract a number on both sides, and the inequality remains the same. Okay, now if we want to multiply on both sides, oops, hold on a second. There we go. If we want to multiply on both sides, right, that's going to be, actually, I'm sorry, I'm writing this all wrong here. Okay, we've got a less than b. Here we go. Okay, a times c is less than b times c if c is greater than 0, or in other words, positive. Okay, so we can multiply or divide by a positive number, and it doesn't change either side. So like we can double both sides, we can triple both sides, and so on, and the inequality remains the same. Now, if we want to multiply or divide by a negative, that's going to flip the inequality. Okay, and we can't multiply or divide by 0 because that's going to mess up the inequality. So if you want to multiply or divide by a number on an inequality, it stays the same if it's positive, but the sign has to flip if it's a negative. That's going to reverse the inequality. Okay, so let's look at some examples. Let's say we've got 3x minus 2 less than or equal to 10. Okay, so I'm going to solve this just like a regular equation, except if I multiply or divide by 0. That's going to be the only difference. So if this was an equation, I want to get x by itself. So the same rules apply here. I want to do the opposite. I'm going to add 2 to both sides. I get 3x less than 12. Now I want to get x by itself, so I'm going to divide by 3. I'm dividing by a positive, so nothing changes. And I'm going to get x less than or equal to 4. Okay, so that's my solution. I can write it as x less than or equal to 4. I can write it in set builder notation. I could write it on a number line. Okay, so we want all the numbers less than 4. And it's included, so I'm going to have a square bracket, same as a closed dot. And I could write it in interval notation. If I go from left to right, I'm going to go from negative infinity to positive 4. And I'm going to have a round bracket on infinity, of course, and I'm going to have a square bracket on positive 4. Okay, so these are 4 different versions of the answer for this inequality. So it just depends on what they're asking. If they ask for you to solve it, to write it on, draw it on a number line, draw it in interval notation. Okay, those are the different ways that you could express the answer. Okay, next one. 2x minus 3 plus 4 less than or equal to 2. Okay, so this one, again, like a linear equation, we need to clean up the left-hand side before we do anything else. So we're going to distribute that 2. So I get 2x, 2 times x, minus 2 times 3 is 6. 2x minus 6 plus 4. Now we can group like terms, negative 6 and positive 4. Okay, again, be very careful you keep the signs with it. You don't want to make this 10 and do minus 10. That would be something completely different. It's got to be negative 6 and positive 4 to get negative 2. Okay, so now we're into the linear form, and we can go ahead and get x by itself. So I'm going to add 2 to both sides, and I get 2x less than or equal to 4. And now I can divide by 2, dividing by a positive, so nothing changes. So I get x less than or equal to 2. Okay, so here's my solution, x less than or equal to 2. I can put that in set builder notation. I can put it on a number line. Okay, so I want to be less than, it's going to be all of this. And it's included, so I'm going to have a square bracket. And I can write it in interval notation. I go from left to right. Let's see, left to right, I'm going to go negative infinity to positive 2. Infinity is never included. Positive 2 is included. Okay, so here are the 4 versions of the answer, depending on which one you need. There we go. Okay, let's try one more. I think I need a little bit more space. Let me come up here. Oh, sorry, this is going to give me an error. I don't know why this program's giving me grief. Eventually it closes out. There we go. Okay, last one would be 3 minus 2x less than or equal to 15. Okay, so this one's already in linear form. We need to get x by itself. So I'm going to do the opposite here. This is like a plus 3, so I'm going to do minus 3. Okay, this negative goes with the 2x, not with the 3. So 3 minus 3 is 0. I'm left with minus 2x. 15 minus 3 is 12. Okay, now to get x by itself, I need to divide by negative 2. This is the one time it's different, right? If we divide by a negative, we need to switch the sign in between. I would recommend that you make some sort of note to yourself here that you're switching the sign. You could circle it, you could draw a line through it, you could put a star over it, something so that if you go back and check your work or whatever, that you remember that or you get distracted and then you come back to it, remember that you have to switch this sign. Okay, so on the left-hand side, oops, those cancel out, we're left with just x. I have to flip the sign. Now it's greater than or equal to, and 12 over negative 2 is negative 6. Okay, so my solutions are x greater than negative 6. Here's negative 6 on the number line. I want to be greater than. Okay, and again, we're included, so this is a square bracket. That's just coincidence that these are all included. And my interval is going to be negative 6 to positive infinity. Infinity is never included. Negative 6 is. Oh, I forgot the set builder notation. X such that x is greater than or equal to negative 6. Okay, so there's all 4 versions of the answer. Okay, now if you want to check any of these answers, it's a little bit different from checking a linear equation. Okay, because we have a range of answers here. So I could check negative 6 and put it in here and see if they match. Okay, so that's one way, is to plug in negative 6 into the original equation. Sorry, inequality. Okay, so I'm going to get 3 minus 2 times negative 6, and I need that to be less than or equal to 15. So negative negative comes out positive. This is going to be 3 plus 12. And is 15 less than or equal to 15? Yes, it is. So that checks. But the thing here is that they're equal. It doesn't tell me if I've got the right inequality, though. Like if I had forgotten to flip this sign, this still would have come out right, but I would have had the wrong inequality here. So another thing that you can do to test the inequality itself, and it might be a little bit more helpful, is to test something that's in this range. So what's something that's in this range that I could test? 0 would probably be pretty easy, right? So I'm going to test 0 and make sure that my inequality is true. So 3 minus 2x less than or equal to 15. I'm going to put 0 in here. Okay, negative 2 times 0 is 0. That whole thing disappears. And I've got 3 less than or equal to 15. Okay, is 3 less than or equal to 15? Yes. So I know that I have the right direction for my inequality from this. Okay, so this one would be testing the boundary. It would be testing to make sure that you have the right endpoint. This one would be testing to see if you have the right range. Okay, and you can test either one. You can test both of them. You can not test it all and just hope that you get it right. But if you want to check it, that's kind of the idea there.